Hey guys, welcome back to Severe Statements, and today we're going to be going over another weather question, and that is, how do tornadoes form? So the worst tornadoes will form off supercell thunderstorms, so we'll go over that first. So a supercell thunderstorm contains one thing that will make it different from regular thunderstorms, and that is it has a vortex of spinny air in the middle, constantly bringing in warm, humid air and dropping the cold air, or the downdraft on the ground, and the updraft causes the vortex to swell and push down, thus creating a funnel or wall cloud. So basically, the vortex will start to spin in the middle, and it will start sucking in the warm, humid air from outside, and then the downdraft of the storm will start to push it into a smaller area, will start to spin faster. And if the downdraft is strong enough for the storm, it will bring it all the way down to the ground and form a tornado and start to pick up debris and form more of a shape. So you can see the vortex from. So if you do have a chance to view supercell from far away, you can't see the vortex. But if you look up at the top, you'll see an area of jutting out cumulonimbus. I'll circle in red right here. That is known as the overshooting top. The vortex is usually right under that. The vortex would be about right under that, because that overshooting top is where you can see all that warm and humid air being sucked into the storm. So if you look for the overshooting top, circle in red right here, on top of the supercell or any thunderstorm, that's usually where the vortex will be. But this isn't really the only way tornadoes will form inside a supercell thunderstorm, so let's go over the other way. So non-supercellic or non-supercell tornadoes are the other way strong tornadoes can form. So for these tornadoes to form, you first need to have a thunderstorm of some sort, or even a strong rain shower. So as long as the storm has cold air circulation and enough shear, the tornado can form. So basically, cold air will vigorously start to spin on the ground as warm air pushes it up, and the circulation will begin to pick up dirt and debris on the ground, thus giving it its tornado shape. So these tornadoes still, on average, will last less than a minute, 30 seconds, somewhere around that, and won't travel very far, but they can still move very fast and come out of nowhere unexpectedly, and produce winds, circulating winds up to 100 plus miles an hour. So if you do see one, seek shelter fast. Another way to tell these tornadoes apart from regular supercellic tornadoes is that they won't be very distinct in their shape, I guess you can say. They'll be whirling around a lot and almost see-through. You might even see two of them that looks like next to each other that will swirl into each other. They're not very strong. They don't look very sleek. As you can see this one right here, you can almost see through it, like see through the middle or even the bottom, and it's just roping all over the sky. They're not as straight and sophisticated as regular supercellic tornadoes, but they're still tornadoes. They can still produce wind speeds 100 plus miles an hour, destroy property, fling cars all over the place. So if you do see one, make sure you seek shelter fast, because these are still very dangerous. So guys, thanks for watching. Just so you know, I'm just touching the surface on tornado development here. So if you'd like to learn more, I'll put some links in the description down below for more resources. So I hope you learned something today, and if you have a weather question, just put it in the comment section down below, and I'll get back with an answer, either in reply or a video. So again, hope you learned something today. Stay safe out there, and stay severe weather aware, and I'll see you in the next one.